Hi, my name is Glenn, and I'm here from Splunk. And I was going to talk to you guys about Node and Splunk, but then, then this little thing happened. So now I'm going to talk to you about IOJS. No, I'm just kidding. How many people here have heard of Splunk? Okay, so for those of you that have not, we are a data analytics product for big data. We take in machine data. That's really what we focus on. And what machine data really is any kind of event, or we call it time series data. So logs is a very common place. You have different types of servers that are generating lots of different logs. And all of that data is time series. And we take in that data. We allow you to search against it and analyze it real time, report against it. Real-time processing is a big part of what makes the product special, is the fact that you can have queries that are just running continuously and never stop, and as results come in, you can have reports that are updating real time. Another big strength of the product is the fact that it can deal with almost any kind of data. It doesn't have to be schematized. You don't have to give it a lot of formatting rules ahead of time. You can take JSON, it can take XML, take loose text files. One of the places where it is really heavily used is in operations. So companies that have lots of servers, they have their operations teams, they use Splunk. We have some really large customers like Comcast, Walmart, really big in the enterprise. But we also have people use us for security auditing. So basically taking in data and mining that data to look for intrusion detection, these kind of things. And we have developers that build on top of us. We have a full developer platform, which is what I work on. And one of the things that we support in that developer platform is Node. This is not responding when I'm hitting it. Why? Hold on a second here. Let me just, for some reason when I'm, oh, now it's working. Okay, it's just going slow. So I'm going to spend the rest of the time talking about Splunk and Node. Now, not only do we allow you to build integrated solutions with Node, we actually use Node in the product. So I'm going to spend the rest of this session really talking about the different ways that Node comes together with Splunk. Feel free to ask any questions that you might have as well. So let's first talk about Node in the box. So we actually do ship Node as part of Splunk. So if you look here, Splunk is a product that you can install on your machine. It supports Mac, it supports Linux, it supports Windows. We have a cloud-hosted version of the product in AWS, but many of our customers, and we've been around for a long time before cloud was even a thing, they run Splunk on-prem. So this is the Splunk installation directory, and if I go in here, you'll see that there's a bin folder here. And you'll see that Node is there. So we actually do use Node in the product. Now, much as I love Node, I don't want to send a wrong message. The bulk of the product does not use Node, but we actually do use it for some very specific things. And I'm going to talk to you about what those use cases are and why we felt that Node was a good fit. So you can see that Node is there. And I'll also, before I jump into how we use Node, I'll just show you quickly the product. It's not going to be a product sales thing. It's very, very quick, just so you get a sense of why I'm showing you what I'm showing you. So let's do that first. So I have Splunk running on my machine here. And I mentioned, so this is the Splunk admin screen. So many users of Splunk will actually interact with Splunk right from this screen. Like if you're an operations person, I can issue queries here. I can set up different types of data that will come in, and I can create reports. So one of the things that you can do is you can basically mine data from APIs. So a pretty popular API that a lot of you guys probably heard of is this thing called GitHub. Anybody here heard of GitHub? No, just some passing fancy. So what I've done is I've loaded up a bunch of data from GitHub into Splunk. So if I go here and I do GitHub, you can see that it's got a bunch of JSON events, which are commit data that was pulled in. And then what I can do is, although that data is JSON and it's very loose, I can actually do queries against it and even do aggregations against it. So I've got sources coming from 3 different repos, and one of those is Node.js. So you can see here that I just did a query to say, show me all GitHub commits from Node. This is not current right now. It's from a couple of months ago. And then what I could do is do like an aggregation. Like I could say, show me counts by author. And then I could come over here and I could do a visualization and say, I want to see that as a pie chart. So just giving you an idea of how you can very quickly go from data that Splunk is pulling in, go and report against it, query it, visualize. There's 2 ways really to get data in. We can pull data from different sources. That's what this is doing, pulling data down from GitHub. And I'm going to talk a little bit more about how we do that later. Or data can actually be pushed in. We have a really scalable way. Like if you have hundreds of thousands of servers, for example, literally with Splunk, we have these little agents that you can install on those servers that will monitor logs and other things, and will push that data into Splunk. And it scales out very, very well. OK. So what's the scenario for using Node? Well, here you see that I have this search result here. Now, I can turn this into a report in Splunk. So we actually have a notion of reports. And here I did a different type of query, which is an area chart. And I'm showing commit data over time. So you can see pretty cool behaviors, what's going on, how things are fluctuating in terms of when people were committing, what hours of the day, et cetera. Now, I saved this as a report. So the first scenario for which we wanted to use Node was to allow you to generate those reports to a PDF. This may sound really simple, but it's actually not. So we have this UI that you can see, which is in the browser, but we actually want to turn that into spitting out a PDF that we can send to you. And why this was useful for us to use Node is because, well, this is some type of processing that has to happen on the server. And there's HTML and there's DOM. And what we really want to do is take a web page and turn that web page into a PDF. So we're doing that with Node. First, I'll show you how it works. I'll actually do it, and then we'll see how it works. So if I come here, I have this export option, and I can choose to export this as a PDF. Hit export. A second later, I now get a PDF representation of that web page that I showed, that you just saw a second ago. Okay, make sense? So what's happening under the hood? So what's happening under the hood is when you click that save button, that's actually making an API call to Splunk. Splunk is really just a big RESTful API. It has many, many different APIs, but every one of them is exposed over HTTP. And actually, whenever you saw me using that UI, basically it's a set of static JavaScript that's running client-side, and it's doing lots of JSON calls back and forth to Splunk, calling APIs. We use things like Backbone, by the way. So what happens there when I click Save is it packages up a bunch of information from the browser, which it sends back to Splunk over JSON. And then what Splunk does is Splunk needs to take that information that's in the browser and render it as a PDF. So it turns out, why Node? Because there's actually really good support in Node for doing these kinds of things on the server. There's a module in Node called JS DOM. Anybody here heard of JS DOM? Okay, so what JS DOM will actually allow you to do, earlier Matt was talking about how I think it was you were mentioning that Charlie had mentioned this, about how you could move processing from the client to the server. And actually Douglas Crockford, who some of you guys might have heard of, who was like, he's the guy who wrote JavaScript, the good parts. He basically, at Yahoo, they did this. They basically moved a lot of processing from the browser clients to the server so that they could support downgraded level browsers. That's not our scenario, though. We actually need to do it because we need to process this PDF. So what JS DOM will allow you to do is actually like create a DOM. You can create a DOM in memory on the server, walk that DOM, and even have some processing that happens. And then there are other modules. There's actually a PDF module that you could then use to basically generate a PDF. Now, these charts that we have, we use some JavaScript libraries like HighCharts, some of you might have heard of, which is a client-side library. So what we basically do is we generate SVG files. And we're doing that with Node as well on the server. So the process that's happening is Splunk is spinning up this Node process, which is going to run some scripts that are going to now process the charts and generate the PDF. All of this is happening, and this is another reason why Node was a good fit. It's all happening in a streaming manner. So we stream data from the Splunk process to the Node process. We do that right over standard in. We don't have to do any kind of like marshalling or anything like that. We're just streaming data right across to the standard in of the Node process. It's going to do its processing. It's going to just write back to standard out. And then that PDF is going to get streamed back, and boom, see it come out the browser. Just to give you a sneak peek, and I'm not the expert at all of this code, but you'll see here, if I scroll down here, that you see this standard in code. So this is the file, this is one of the files that will get launched. If I'm not generating a map and I'm just got like a report or a chart, this JavaScript file is going to get called. This JavaScript file also ships as part of Splunk. And scrolling down to where I have, you can see that I've now opened up, I'm now grabbing the standard in. So I'm grabbing that input stream that's going to have the data that Splunk's going to send over. And you're going to see this pattern recurring when we look a little bit more at how we use Node with Splunk. This idea that we just open up a process, we just send stuff over standard in, get stuff back over standard out. It's a very Unix-y way of doing things, and our company has a very big kind of Unix foundation there. So now I'm just going to chunk up the data. So for those of you that have not worked a lot with Node, Node has a really prominent feature called streams. And streams, you can connect them, you can pipe them together, and streams are just continual flows of data. They can come in, they can come out. And it offers, because of the fact that Node is all async, it's designed to handle streaming in a very efficient way. It doesn't block while it's waiting for data to come in. So you can see here that I have this standard in on data. So this standard in object is actually a Node stream. And so I know that it will have this on function, which is going to basically be like an event. As data comes in, this will get called. And now what we're doing is we're concatenating that data as it comes in. These are not too huge, so we don't have to worry too much about memory. And once that's done, we're going to turn that into a JSON object, and then we're going to pass that off to do the processing. And then you'll see, if I go into like node charting here, you can see where I pulled in JS DOM, because I'm actually going to be working with a DOM, creating like a HTML page and things like that, working with a DOM. Loading up jQuery. So this is a really cool thing about Node. It's all JavaScript. We use jQuery. So what we're doing with JS DOM is we can actually load up jQuery and load up other JavaScript libraries right in memory. And it's kind of creating a browser basically in memory that can do all the processing, which is very similar to kind of what the Yahoo folks did. So you can see a bunch of work that's going on here, but ultimately what it's going to do is write back that PDF. So you can see I have this get SVG call, and ultimately if I go back to the original caller, that data is going to then get streamed back. There's the PDF. So very tactical usage of Node, but one that worked really, really well, because in the case of what we were trying to do, we really needed completely that ability to process JavaScript on the server. That PDF module that we're using, that works client and server. But we didn't want the rendering to happen on the client. We wanted that rendering to basically happen on the server. Any questions on that? Yeah.
Do you know why the Phantom.js was used instead, which is basically the same thing, but has an entire suite of it?
Yeah, we looked. I know that early on we looked at Phantom, and there were a bunch of issues around it in terms of installation requirements and things like that. Phantom is heavier in terms of the way that it works, because it requires things to be installed on the machine. Like you have Phantom.js, but then you have Phantom itself. So I don't have all of the details, but I know that it was something that was investigated at some point, even as an alternative to what we have now. There are other modules that you can use also for parsing the DOM, like Cheerio. if you want to do any kind of DOM parsing on the server, there's a module called Cheerio. But Cheerio is really good just for kind of looking for elements. It's not going to actually execute code. The beauty of JS DOM is like if I load jQuery up in there, I can actually call jQuery functions and they will execute on the server, which is a pretty, really neat, I think, thing. I mean, just get your mind around that one. Which is what made it attractive for what Douglas Crockford was using it for in Yahoo. Because they were basically able to say, this is a browser that can't handle doing this kind of JavaScript on the client because it's downgraded. We'll just move that processing to the back end and just give them the final rendered output. So it's pretty neat. Any other questions before I move on? Yeah. I mean, you could at your own risk. The JavaScript files are there. So they're in a folder. As a matter of fact, they're living in a PDF folder, which is within your Splunk installation. So you absolutely could either just read it to try to understand how it works, and you could tweak it. But you'll very likely find out when the next version of Splunk comes and you try to upgrade it that it's gone, or you'll have to deal with diffing. So we certainly don't recommend that you do that, but that doesn't mean you can't do it. Source is there. You can do what you want with it. Okay, so I'm going to move on. How are we on time? Yeah, but what do we, I just get a sense. Okay. All right, so there you go. So the next thing I want to talk about is we found a lot of customers wanted to be able to access Splunk from their mobile device. And so you could just run Splunk's browser application on the device. I mean, it's a browser app. You could open your browser. But it's not like an ideal experience. And what customers really wanted was a rich, kind of responsive UI. I don't mean responsive in the webby sense. I mean actually like responds well, works well. Because responsive UI is a whole new term these days. Matt knows something about that. They wanted things like push notifications so that I could have reports that periodically notify me. Splunk has this ability to do these things called alerts. And so they wanted to be able to say, hey, I kick off a report, it runs for a while, results come back, I find out about it through a push notification, which means the app could actually be closed, and it gets the push notification. And they just wanted that richer kind of experience that PhoneGap doesn't give you yet, but tries. So we created the Splunk Mobile Access Server, but the challenge that we had is that Splunk has an API, but there are things that we still wanted to take advantage of the fact that on a mobile device, like on an iOS device, there is a browser for the rendering of charts and things like that. We wanted to reuse the code that we had on the server for generating those charts. And there were a bunch of issues around being able to access that functionality. There was no easy way to do that directly with a mobile device, the way that Splunk's API is set up. So solution was to come up with this thing called a mobile access server. And so the mobile access server, customers who want to use Splunk Mobile and they run Splunk within their environments, this is something that they can easily download as part of Splunk and they can run it in their environments, this mobile access server. And what it basically does is if you look at this topology, this diagram here, the bottom part is like conventionally how people talk to Splunk. But now this mobile app needs to access some things that are not easily exposed that a mobile device could get. So, like some of the charting and things like that. So what we basically have is a proxy that's set up. And one of the other reasons was we wanted the authentication model to be a little bit different as well. So we set up a proxy, and then that proxy will then take requests that come in that think they're actually talking directly to Splunk's API, but they're not. And it will send that to this mobile server that does some additional processing and things like that. So again, we use Node here for a bunch of reasons. So for the proxy, there's Node HTTP proxy, which is a really popular Node module that's out there that is a lightweight way to just proxy requests. So we use that. We used Express to do some authentication. So what we wanted to have, again, was the auth model was going to be slightly different than what we had in Splunk. And in this case, for what we were doing for mobile, we didn't want to rip apart Splunk's existing auth model. So we were able to do it this way as more of an add-on. So we utilized Express, which has a lot of middleware that can do different things like authentication for tokens and things like that. And then we also used Koa. So we used Express also in a very limited way. Now, for those of you that don't know about Koa, Koa is like a fairly recent new web framework. And one of the reasons we chose to use Koa, how many people here have dealt with callback hell in Node? Everybody who's written Node code has dealt with this. So if you've been following Node as it's progressed, in Node 11, you have these things called Harmony proxies. And Harmony proxies, with Harmony proxy, you can use what are called generators. So generators is a new thing that is coming in ES6, which is JavaScript, that is going to provide an easier way to write async code. It's bringing coroutines, basically, into JavaScript. So it makes your code a lot cleaner. So this app is actually running on Node 11. And it is using, the reason why we're using Koa is because Koa has embraced generators deeply. So Koa is like a web framework that's trying to make it easier for you to write async code by baking in support for things like generators. So you can see the generator code here. So many of you, if you've written Node code, you've dealt with things like lots of callbacks. And what you have to end up doing is you do a callback, and then when that callback finishes, you then nest down. That's where the kind of Christmas tree happens because of the fact that you're nesting and nesting and nesting. But here what you can see is that var all apps equals yield app call.getAll. Well, getAll is actually code that is making some async calls. Normally, if I was doing this without using generators and using co, which is what Koa is pulling in, I would have a callback there. But in this case, you see I don't have a callback here. I'm just calling getAll, and then I've got the next code that I want to run after that. But I've got this yield keyword. So the yield keyword is part of ES6. It's part of generators. And so what this yield keyword is basically going to do is it's not going to continue to the next line, var entitle apps, until getAll completes. But getAll will still complete in non-blocking fashion. So it's sequential, but it is still non-blocking. And this is a key aspect. This is one of the things that a lot of Node developers are really excited about in ES6 is the fact that these things called generators are coming. And they're going to be in Node 12, right? Once Node 12 finally hits. Or IOJS, which might get there sooner. Yeah, a lot of people have been really wanting this feature. As a matter of fact, my team, we kept hounding Joyent, trying to find out, like, when is Node 12 shipping? Because we really want to use the production version of this. But it's exciting that JavaScript is getting some baked-in support to make async code better. You guys see the difference between the code I'm showing here and the code many of you are probably writing today? Yield makes things a lot better, and generators make things a lot better. But it doesn't go far enough. You do need helpers like Co or other modules to really get a nice experience. Yeah, go ahead.
Are those effectively like just right, as if you had written the callbacks? Like, is there any difference other than just that it's
Performance-wise, there's really no difference. But Co makes things a little bit cleaner. Like it's not. There's a little bit of magic that's going on here. When you just use generators by themselves, it's not enough today. So there are still some modules that you really need to get the rich experience, but fortunately those modules exist. But the core functionality that allows you to have this thing called a generator that can yield, those things are built in. If you, Creationix or Tim Caswell has some really good posts on generators if you want to understand what generators are and how they work. Yeah? That's a great question. What's the difference between generators and promises? Well, promises are an API. Promises are an API that basically allows you to say, okay, I'm going to make a call to a thing. It's going to return me a thing called a promise. And then promises can be chained together. The difference, I would say, is that promises are really just implemented through an API. So you have to write your code. You basically have to write your code in such a way that promises are viral. So you basically, to have a promise, you have to have something that returns a promise. And it works. It solves a problem in that it makes the code more manageable, less like this nested callback hell. But it still requires quite a bit of work, and it's not a first-class part of the language. Like, they're adding promises into JavaScript, but that's like the API of promises will exist. The difference with the generators is they've actually changed the language. Does that make sense? So it's a much more first-class support. Yes?
Had a lot of issues since this is like edge node, like stability issues because of this?
Yeah. I mean, it's been pretty stable. Like Node 11, early versions of Node 11 were really, really unstable. So far, from what I've seen, they've been pretty happy. Now, admittedly, the app is very limited in what it's doing. So it's not like we're building a full-blown, really complex web app fully in, using Node 11. But yeah, I mean, ideally we would like Node 12. But I think it was, what I can say is that my developers who built this, which are in Shanghai, they basically found that using Co and using generators and using Koa, the module, made a huge difference in terms of just maintainability of the code and ease, because you just didn't have to deal with that callback hell. So if nothing else, I would take away that there is stuff coming in that's going to make JavaScript better in terms of writing async code. Better maybe is in the eye of the beholder. One more question, but then I got to keep going because I'm going to run over on time. Yeah. Yeah, Matt.
Yeah, I was just going to say, I'm not sure that this is not to point your code or anything, but I'm not sure this is a realistic example because with yield, you would need to do some kind of try-catch around any calls.
You mean if there was exception?
If there was an error.
Fair enough. True.
A callback, you'd have an error as the first argument, but here you only have one return value, so you'd have to do a try-catch.
True.
Make your code look even more disastrous.
What, you mean adding try-catch? But you won't have the nesting. I mean, you'll have try-catch exception code.
Yeah, I just think try-catch looks like
Fair enough. Fair enough. Okay, yeah, but you could also wrap multiple calls around try-catch. Like the one thing that's also nice, by the way, about generators, you can actually do like a for each loop. So, a lot of times when you start moving into the node world, things that used to be really simple, like I'm just going to make I'm going to do a loop that's going to go and make a bunch of calls, becomes a lot more complicated because in languages like Java or other languages, Ruby, that are not async, inherently, everything's going to be sync. So you can safely do that loop and just call this, call this, call that. That starts to get a lot more complicated once you start doing things in an async fashion. There are modules like async that help. But in this world, when you use generators, you actually can do like a for statement and just loop through and safely make those calls. Okay. So as is normal, I'm over on time. So the next thing I'm going to talk about, so I kind of gave you an idea of the mobile server. So that really covers the two primary places that we're using Node within the product itself. But then we have a lot of customers that want to use Node. And Splunk offers the ability for customers to both integrate with Splunk so that you could have an app, for example, that's querying Splunk, much like a database, pulling data out, doing real-time queries, and returning those results. And what we also have that's very new, which is something that I was pretty involved with, is the ability to actually extend Splunk in Node. So I'm going to talk about both of those now. So first off, we have a Node module called the Splunk Sdk, and the description there is actually wrong. The Splunk Sdk actually it includes two things. It absolutely includes an SDK for working with our API. We actually use the request module pretty heavily. That's like our standard that we use for making HTTP calls. We've been really happy with it. If you're doing a lot of HTTP calls, I recommend you check out request. But the SDK also includes server-side extensibility for extending Splunk itself. So the difference between the two scenarios is this. The person who's using the SDK for the API has an app running over here, and Splunk is out there, and they basically want to be able to pull data from Splunk, do queries, management, this kind of thing. The extensibility story is where you're actually deploying something into the Splunk instance that we will basically invoke for doing something. And we're going to talk about both of those right now. So, extending Splunk, which I think is the more interesting one, we have this concept in Splunk called inputs. And inputs are ways to bring data in. Now, I mentioned before how we have this ability to deploy these agents that look at files and pull data in from files. Not everything comes from files. So you might actually want to look at processes or maybe even invoke APIs, as I mentioned. You might want to pull down some data. To give you an example, there's a Splunk Box App. And the Box App is an app that you install into your Splunk instance. And if you have a Box account, you basically configure your Box credentials. And then it will go to connect to Box and pull it to pull down activity about how your Box account is being used. So this is more interesting for an enterprise type scenario where they want to manage and see who's using what, how much data, this kind of thing. So doing that is actually extending Splunk. And we have this concept in Splunk called a modular input. And recently, we added support for doing this in Node. So the way that this actually works is kind of similar to the PDF model. We will spin up a process that you author, or you will author a Node program, so to speak, which is an extension. We will spin up that process once you've configured for Splunk to spin that up. We will send it data over standard in, which will be a bunch of metadata about how that input is supposed to function. That input then does whatever it wants to do. So it goes and connects to some source. It could be local, could be talking to processes, could be making API calls. And it streams back results directly to Splunk. So what I'm going to show you now is an example of that. And if you saw earlier on, I showed you about mining GitHub commit data. Those GitHub commits actually came from an app that was authored in Node as an extension to Splunk. And you can, if you're using Splunk within your organizations, and by the way, to get Splunk, you can download it for free. Our model is based on how much data that you ingest per day. We give you 500 megs of data a day free. So you can use it as long as you want if you're just doing 500 megs of data. For many small types of things, that's fine. Once you start getting into large amounts, we have customers doing petabytes. So it's, and that's not free. But you can get started very easily using it for your own types of uses, like reading log data and such. So let me show you that example. Can you guys see my screen okay? Is it too small? Okay. So within Splunk, we have this concept called inputs, as I mentioned. And you'll notice that I have this thing called Github Commits. And if I zoom in on that, you'll see that I have 3 repos that I am pulling data from. And it asks me for information like who's the owner, what's the repository, what's the token. Because I'm going to use GitHub's API. And GitHub's API, if you don't use a token, it's going to rate limit you. If you use a token, you have a lot more flexibility in terms of how much data that you can pull down. They don't charge you for creating the token. I think it's more about it gives them more data because they know who you are, or they at least know that you've created a thing called an app, and they can classify it that way. So if I go here and I click New, you'll see that it gives me a UI. Recently, they made some formatting changes, which broke it a little bit. But you can see here that it prompts me for name, owner, repository. There's even validation that will run. And once I've configured this, then what it's going to do is it's going to pull GitHub and pull down commit data. Now, some APIs might have a streaming API. So it might be fine to say that for that API, I just open up, and I use like WebSockets or something like that, and I just pull down that data continually. But in a lot of cases, like in the case of GitHub, you really have to do something like polling. So anyway, you can do these kind of things in Node. And I'm going to show you that code right now. So Splunk has this notion of these things called applications. And this is an app. Now, if we look at this app here, you'll notice that there's a command script and a shell script. So we are basically running the node that is built into Splunk. This CMD is a command that will automatically set some environment variables to find things like find our node version instead of the node version that may have already been installed on the machine, because we have a specific version. And it's going to just run that JavaScript file. So once it runs that JavaScript file, that's going to now launch a process. And then that process needs to listen over standard in and write over standard out. Now, you could just do that, but that's going to be quite a bit of work because we send metadata in a certain format. So what the SDKs will do for you that's really nice is they'll give you a really nice programming model for working with that, so you don't even have to know about standard in or standard out. So for this particular example, because of the fact that we're going to go against GitHub, we're going to use the GitHub node module. There's a GitHub node module which allows you to basically integrate with GitHub's API. And you can see here that I'm requiring Splunk's SDK. Now, one of the things you'll notice, which is a little bit of a thorn, I would say, is years ago when we first wrote the Splunk SDK, there was this little module that was coming up called async, but it was early days. So we kind of created our own mini async, which you don't have to use, but it's there, and we're using that in this example here. And then you can see that I'm requiring the modular inputs library. And the modular inputs library, that's going to give me the API that will allow me to interact with that, with the infrastructure of Splunk to basically be able to send events back. Now the model here is you author this as a module. So when we were trying to think about like what's the best way to implement this in Node, we said really in the Node world, everything is about modules. So the idea of how you write an input is you basically have a module that exposes certain functions. And one of those functions is a thing called a scheme. So when I went into that input that I was just showing you, you see these values here, like name, owner, and there's descriptions. I think what's nice about this model is you don't have to do any config files. This is basically the get scheme will return this scheme object, which is populated with arguments. And what will happen is when that data gets sent back to Splunk, it will read that data and it will use that to populate the UI. You can even do things like validation that way in a declarative fashion. But in this case, there's some specific validation I need to do because you're giving me an API key. So what I want is, and you're giving me an owner and you're giving me a repo. So I really want to be able to run code that right away validates when you go to click save that, hey, that repo doesn't exist. So what you can do is you can implement this validate input function, which you can see takes this thing called a definition. And from the definition, I can pull out the parameters that the user has specified. So now you're seeing that protocol again. So I was just in the UI here. I went and clicked save. Immediately what will happen is that node process is spun up, and that validate input will end up getting invoked, where I can then do my logic. Where in this case, the logic that I'm doing is I'm instantiating the GitHub API, and I'm going to try to make a call to GitHub first to validate the token, second to retrieve the repo that you told me that you want to retrieve. So if anything happens, I can communicate that back to the user. And then the last one, which is the most interesting, is actually the thing that does the streaming of the events. So what we basically have is this thing called an event writer, which is actually a stream. We implemented this as a node stream. And so what I'm going to do within this particular event is I'm going to talk to the GitHub API using the information that was given to me. And I'm going to make a request telling it to basically get me whatever data is new from a commit perspective. Now, I can run this actually continually. It's not running right now. And we have the ability to persist a file, because we don't have a database or anything that you're using within Splunk. Persist a file that keeps track of the last commit that was hit the last time that we fetched, so that we can resume. So high level, what this basically is doing is we're now extending Splunk to be able to talk to GitHub. And you could use this to basically talk to any kind of service you can imagine. And why Node is really nice is it just has a really rich ecosystem, going back to that ecosystem, of modules that will come in useful when you decide to build something like this. Like if you want to talk to AWS, there's an AWS module. You want to talk to Rabbitmq, there's a Rabbitmq module. So you can use this as a way to basically bridge to get data. StrongLoop has done a blog post about actually using Splunk and getting data from StrongLoop into Splunk. You could also do the reverse and have an input that basically talked to StrongLoop and pulled data out and pulled it in using this kind of mechanism. Any questions on what I showed here? Yeah?
What kind of stream is it?
In terms of from a node stream perspective, it's an object stream. So we let you stream. So you'll notice that that's a great question, like what kind of stream is it? So we made this an object stream because we want you to be able to just be dealing with JSON objects. So you can see here that I'm calling this event writer.write event, and I'm passing in the event. But that's not done in an async fashion. And that's because under the hood, this is actually a stream. So you can actually use a streaming interface directly, but we just wanted to make something that was a little friendlier. But you can see here that I'm newing up an event object. I'm just setting some JSON properties, and then I'm passing that event on. Now what will happen is although it's an object stream, at some point it has to get translated into the raw underlying stream. So that's the infrastructure of the SDK. Like you basically will stream those objects over, but on the other side, the receiver of that stream is then going to take those the object payload and dump it out to JSON and send it back across the process boundary through standard out.
Is this some extra process when you do an event writer.write event instead of just pushing the data into the stream? Are you doing something else before you send it across? Or?
The only thing we're doing is actually translating it to the raw stream. Yeah, there's some buffering. I think we have some buffering and other stuff that has to happen. The standard output stream can get backed up, so I think there's a little bit of logic there, but it's not heavy. It's definitely not blocking. This is kind of fire and forget. The reason why this works is when you call write event, it's basically a fire and forget operation, so there's no need to basically like wait until that event was written successfully, which is what you would do in an alternative to this model would have been a callback and a success, and it doesn't continue until that. But we didn't need to do that in this case because of the fact that it's fire and forget. Make sense?
Yeah.
Cool.
What about the inverse? Do you have node processes that can get data from Splunk and then do other stuff?
So not within Splunk itself. That is something we're looking to add. That's a great question. We have this feature that we're calling modular alerts. Splunk has an ability to do things called alerts. An alert is like you run a search. If any results come back, based on those results, you can run a script. Today, you can run Python scripts, but the API is not fantastic. So we're overhauling that, and I'm sure that Node will be one of the things that will come out of that. What you could do today is use the API and write your own thing that runs on the app. Actually, you can do some interesting hacks because of the fact, we love hacks. Because of the fact that the mod input is getting launched, there's nothing that would stop you from within the mod input talking back to Splunk. And we actually have done some stuff like that actually internally where we launched an input that then does some processing and talks back to Splunk through its API. It's actually provided an authentication token because of the fact that it's like trusted code because you have to install it on the machine. It has the ability to talk back to Splunk. So there is a way you could do it, but it's not something we're super proud of. It's more of a hack. Okay, so the last thing I wanted to show you is I mentioned how we have this SDK. And so using the SDK, you can do things like query Splunk or send data to Splunk. And in the spirit of machines, I actually have this pretty cool machine here called a Tessel. Has anyone heard of Tessel? What's special about Tessel related to Node? It can run it. So a Tessel is a board that, similar to Arduino, but the difference is if I program Arduino, I'm writing C code. And the Tessel I program in JavaScript. Actually, I think it uses Lua under the hood. But the end-to-end experience is really nice. I could just write some JavaScript code, run it, and it runs on the device. So how that relates to Splunk is the fact that first, I've actually been working on trying to get it so our Splunk SDK runs actually on the device, but right now that doesn't work. Tessel is still a work in progress, still evolving. They've got some great support for lots of node libraries. I could actually use request, for example, because I can take this device, connect it to wireless, and have it basically make Wi-Fi calls, as long as the Wi-Fi network is one of the types of networks that Tessel can work with. But what I can also do is just stream back telemetry from the device across this USB cable to my computer, and then I can take that, or to my laptop, and then I can take that JSON data and just feed that right into Splunk, and I can do that using the SDK. So I'm going to show you that, and then I will basically be done. So the way that you use Tessel is you basically run this.
How do you spell that?
Tessel, Tessel. They just had a huge sale. They were selling it for Black Friday, extremely marked down. It's not as, I think it's a little more expensive than Arduino, but what's nice about it, you'll see, is the experience. So the first thing I'll do is we'll let Tessel say hello. So I have this Tessel CLI that I install, and I get that through npm install -g Tessel. And I'm going to do Tessel run blinky.js. So what it's doing is it's downloading a node program to the Tessel device. It's deploying it right now. And I don't know if you can see the lights blinking. It's not as impressive as the previous demo, but there are lights that are blinking there if you come up close. And so you can see that this may look like it's code that's running on my machine locally here, but it's actually not. It downloaded this node program, which is requiring the Tessel module, and then it's manipulating the LEDs on this module. But the cool thing about Tessel, it has lots of plugins, like an accelerometer. It has, you can get like a GPS for it. It has an ambient light detector. And what I love about it is the fact, and it does need work, but the end-to-end experience, I think they've nailed. The fact that I can just write some node code, go, run it, and it like if I want to use Raspberry Pi, for example, which a lot of people use, right? I have to like mess around with Linux, set up my Raspberry Pi box, SSH into it. None of that is there with Tessel. It's like get the board, write some JavaScript, profit. Okay. So what I'm going to show is using the accelerometer, and I'm going to use the accelerometer to then send data into Splunk. So what I'm going to do is I'm going to say, I have this Splunk logger.js. I'm going to do Tessel run, and I'm going to run the accelerometer, and I'm going to pipe that into, this is the beauty of Node here, it's just piping streams. So I'm piping the result. The result is going to get piped out of the Tessel back to my laptop, and then I'm going to pipe that directly into Splunk. So it's deploying. And now I'm just going to create lots of big data. So I'm using the accelerometer here. This is like the height of big data, folks. You're seeing it right here. Okay, so that's done. So now if I come over to my Splunk instance, and I was telling you about how Splunk can just deal with really any kind of data. So I can say index equals Tessel, and you can see the results have poured in. And then I could even do some type of visualization on that. You know, give me like a chart or something like that. Pie chart doesn't work. Let's use like a line graph. Okay, so I've taken those results out of the Tessel, fed them directly in, and I've done that with our SDK. And just to show you what the SDK code looks like here, so we have this object called a Splunk service. You pass it credential information. So this is my Splunk login, password, port information. You wouldn't want to do this in a browser. And this SDK is actually usable in the browser as well. And we use Browserify, which is a cool node module that allows you to basically take your node modules that you write on the server and actually reuse them in the client. So we're actually using Browserify so that our SDK is actually usable on the client as well. And you can see here that I'm logging in and it's async, so I have that callback that has to run. And then what I'm going to do is I'm calling this function on that service object called log. And I'm just creating a JSON object, which is going to have within it the data that I received back from the Tessel. So you can see here that I'm passing this thing called a chunk, which is basically the object that I got back. Well, it's raw at this point. It's a stream. And I'm passing in some metadata to Splunk as well to tell it how to index it. So there you go. So that's just an example of using our SDK. Our SDK can do a lot more than that. So this is just a quick view of some of the modules that we're using within Splunk and within our SDK. Probably Requirejs is the one that's most popularly used. But we also use JavaScript and Node as part of our build system. So we use things like JSHint and Grunt. I'm sure many of you have heard of Grunt, which a lot of people use Grunt and don't realize it's actually Node. So we are using a lot of the Node.js toolchain as part of our build process. And this is where you can go to get more information about Splunk. If you go to dev.splunk.com, you can find out about our Node SDK, both for extending Splunk and for using our REST API. And that GitHub example is there as well. We're also all open source on GitHub. So if you go to github.com/Splunk, you'll see all our repos. And we have a Splunk JavaScript repo, which is where our Node code and samples are as well. And feel free to ping me if you have any questions. And thank you guys for having me.